Okay, good. Yeah, I'm still recording. Right, now let's move on. So another example here, you have two filters. You have the solution?
Yes.
No.
I thought you said you want solution.
We have the solution here.
No solution.
No, blank.
What you have.
Oh. Okay, so let's take a look here. Okay, how to do this one? It's quite simple. Calculate the cutoff frequency. So this one is low pass or this one is high pass? Low pass. This one is high pass. So one low, one high. Okay, can you calculate the cutoff? So let's start with this one. PF. What is the cutoff frequency? 2 pi RC. Can you all help me? Since I don't have the solution. What is it next page? Okay, never mind, we work together. So can you work out for me this one? 2 pi times RC. R is 20K times the C, which is 22, right? 22 nanofarad. Can you work out for me, please? What is the FC2? This is FC2. 361. 361.7 hertz or kilohertz? Hertz. Okay, hertz, thank you. Okay, how about the FC2? FC1, I mean. The other one. 1 over FC1 means for the high pass. So 1 over 2 pi times R, right? 27K times 56 nano. So can somebody help me? 105.2. Okay, thank you very much. 105.2 hertz. Okay, you all got it? We're really done already. Part A. Sketch the frequency response for each filter and indicate the value. Quite straightforward, right? So one is a low pass, one is a high pass. Okay, so if I were to quickly do a small sketch here, a low pass looks something like this, right? Comes out, right? So this is the cutoff, FC2. Is it okay? It's actually the same as in your notes. Okay, for the high pass one, it will look something like this, right? Is it okay? So this is the FC. Okay, so you can sketch. This is the FC1. Okay, so this is for the high pass. This one is for the low pass. Okay, it's actually in your notes, the same one. Okay, low pass, high pass. Sketch, done already. Okay, now show a circuit diagram how the given filters can be cascaded.
Join them together.
Yeah, join them together. Cascaded, the word cascaded means join. Okay, how to make it into a bandpass filter. Okay, which is actually the one that we did. It's actually this one. That's why I show you the one. There is one. You take a low pass, basically the answer is this. Very simple. You take this one, this one connect to here.
Yeah.
Then this is a high pass, this is low pass. You connect these two circuits, you get a bandpass filter. That's the answer. Low pass, high pass combined. So what it means is that the output of this filter goes straight to the input of this one. Yes, just connect that. Low pass, high pass, that's the answer. Connect the V out from the low pass to the V in. It's actually in your notes. Just combine. Okay? Can I? This one? So far so good. Anything? Any question? You got a lot of practice inside your tutorial, I think.
So this is part of the small question.
This one, I tell you, exam will be tested. This one, this type of thing, exam will be testing you. So all these are important. Especially bandpass filter. It will test you, calculate determine what is the Q factor, Okay, you know. First order only, very straightforward, no second order. This one cross out. For those of you who just came in, this one you can cross out. The second order active filter, cancel it. Take a ruler, put a pen draw around it. Cancel off. Second order not tested. Okay, only the first order active filter will be covered. Okay, any question so far? Filter? So far so good. So far so good. I mean, I've got a video recorded. In case you need some refresh, you can go and check out my video. The last one I already uploaded on. The last lecture last week one I uploaded to YouTube. I did it on Saturday, Sunday.
That's why you mentioned these two of them to join up to become Bandpass.
Yes.
From the V up to the V.
Yes, correct.
This one both V in only. The V up never go to the other V.
Oh, that one, yes. Because the one I show you is individual. Yeah, but in order to have a... Maybe I have to sketch. It looks something like this. Okay, to be what you call it, complete. Okay, this will be your actual one that you should do. Okay. Yeah, this is the one that I was saying. Okay, see. So this is your low pass, right? This is the high pass. These two is a complete circuit for a band pass. This whole thing is a band pass. Whole thing. That's what I mean. Huh? No, it does matter. It must be low pass first. It does matter. Good point. Good point you ask. It is important. Low pass first, then high pass. Because the cutoff frequency of this one is higher.
High pass first, then low pass.
Huh? Where? Which one?
For example, just now the graph.
Which one?
This one, A.
Low pass first, after go high pass.
Yeah. So this is the FC2. Okay. FC2 greater than FC1. Which one? Where got show band? Low pass, high pass, where?
This is just to illustrate. This is just to illustrate for the actual.
This is high pass. High pass go like that. Low pass, you go from here down here. You combine both, you get this overlay. Low pass first, then high pass. Okay, then Bandpass will be a good question to ask in your exam. Yeah, Bandpass, good question. Okay.
How many marks?
Huh? 7-8 marks. Maybe easily. 7-8 marks easily, for the filter question.
So it's in the rate of 25.
Not bad, no? Quite good. But of course, I still got other parts to do. Maybe or 8. You look at your past sample exam paper, you can roughly see. Okay? Can any questions so far? So far, so good. Okay, this part is nothing much already. This part nothing much. This one just for show only. This picture.
So only no tested.
No. Can cross it. Cross. Okay. Okay, no, you're okay, filter. Any more questions before I comment? Any more? Anything? Any query? Not sure. Filter. Any part? But of course, you can watch the video again. You can recap again. So I will upload this video over the weekend. Topic 5 to topic 5. Topic 5 still got some more. Topic 5. Yeah. If you look at the lesson plan, maybe good to prep you. If you look at your lesson plan, right? After the common test next week, you have a 2 weeks break. I think it's a 2 weeks. 2 weeks break, then you come back, right? You look at the first page of your lesson plan. This one, look at your lesson plan. Okay, now you see over your lesson plan, now is what week? Today is the week 8, right? 12th of December, which is Friday today. So next week you will have common tests. Now, just to inform all of you, next week, right, there will be no practical. All of you will come to here. I think another room next door will be booked. This is 07, right?
Yeah.
There will be a room 08 to be booked. So that 6 and 7 will be booked. So that each class, Mr. Chan and I will come at 6:30. Each of us will take one class for tutorial just to revise first before the common test. Then 8 o'clock, you all will combine. Then you will have a common test. Mr. Chan will invigilate. Okay. Then after common test, you go home. Then that means after you all go for 2 weeks break, right?
Yeah.
2 weeks break, then come January when you all come back, right? After Happy New Year, all those things you come back, countdown and all those things you come back, right? January the 9th, you will go for, you will have continue my topic 5 lah. Okay, and then for those of my group 1, you all will do practical. Then you all will stay for tutorial. So my group will do the first week January. You all will go back and do practical. Okay. Drop 23 level 3. Okay. Then the other group will do tutorial. Then after we will swap again. We'll continue the rotation. Same thing. But week 13 or 16 January, you have a short quiz. My short quiz, I will tell you what to study. You will cover only topic 5. One topic. Mr. Chan one will not be covered. Will not be tested because you already tested in the common test. So no point to double testing of the thing, no point, right? So you only cover on topic 5 only. For my short quiz. Is that okay? Is it correct? Can So but common test, Mr. Chan will tell you, alright, you all will cover topic 1 to 4. Can
So you remember to see the common test paper first. Then we do the revision.
Okay, good pointer. Thank you. Noted. Okay. Look by Monday or something. Okay. So is it all clear? Okay, come on, let's move on. This one, not yet lah. No. So this one important. This one. A few more slides. This one will be tested in my quiz. That's why I want to go through with you. Still not early, 9 o'clock still early. Come on, friend. That one cross out. This one cross. This one cross. Okay, that one cross. That one not important. That one small illustration only. This one also cross. This one cross. This one also cross. These 3. This one cross. This one cross. This one cross. Okay. This one don't cross. This one. Okay. We're gonna just touch on this one. Quiz. Yeah, that will be needed for the quiz. Okay. So can we start this one? This one only we go through quite quickly. But can I remind you, the common test, please study. Please study. Really, because the reason why I say that, because over the years, we always noted that.
Sir. This one you can already say it. Because I see your video, you every lesson also say this.
So that's why I say important. That's why I very long-winded. Right? Also, I'm telling you.
Your every video also have this sentence.
No, really. No, this is telling the truth because I have data to see, right? I have statistics.
But with your video to see.
I know. Common test, please study, okay? Because the tendency is student never make it for common test. When I see the result, I can correlate. The exam, final exam, cannot make it, also a problem. I hate it. You know what I mean? So please study. That's the message. Okay?
The common test got only question 5 question.
20%. I think of 5 or 6 questions, I can't remember, but roughly around. Because Mr. Chan says it. 5 or 6. Okay? So please study. Okay? If you have to take leave half a day or 1 day to study, please do so. I know next week you all got a lot of tests, right? Huh? 2 what? Okay, but spend some time. Okay, so let's move on. Okay, not to hold you, we want to finish. Okay, now I think this is a picture I think you may have seen before. A few years ago, I think 2 years back. Remember there was an incident, right? Remember this one? This one oil rig, then MOM jump. Ministry of Manpower. Wow, big problem. This one. Why? This one dangerous. A lot of workers got hurt. This case. So and I ask you, is reliability important? Yes, of course, right? Because it concerns our lives, right? Especially workers on the ground, right? So this thing happen. This thing slanted, no? Scary, Okay. Reliability, yes. Especially equipment or components, things can happen. Okay. Now let me just touch on this. Reliability. Now when we talk about reliability, right? Okay, we talk about whether the probability of the thing will fail or don't fail. Okay, now what if I ask you what is the probability of this chair breaking apart? Very low, right? Because you probably have tested this, right? If you sit on it 1,000 times, unlikely it will break. But of course, now what happens if I put this chair under the sun? What happens? If you put this chair outdoor, it can tahan, can support. Why you say it cannot last? Why? Heat, yes. Heat is always a very important part in any engineering you do. Okay, so don't leave your handphone in the car, common sense. Why? Cannot, right? Obviously you know. Don't leave your laptop or computer in the car, then you go under the sun. Your computer or something will go haywire. You know why? Thermal heat. Okay, of course there's a difference, right? If I keep this chair in this room, aircon, this thing can probably last me 10-15 years, no problem, right? But if I put this outside, maybe 1 year or maybe less, this thing will die. Okay, because of heat. Okay, so let's talk about reliability. Okay, it's important. Okay, because of things like environmental factor. Okay, it's important. Why? We talk about reliability. So reliability is given by this term called RT. Okay, I'll explain to you later in more detail. RT. We cannot predict when this chair will break. Right? Can you? We cannot. There's no way. But we can roughly give some probability that the thing will break. Okay, you understand what I mean? We cannot definitely tell him this chair will break by 2016, 14 February. We can't. We cannot tell. We will tell maybe this chair will break sometime in 2016, maybe between March to June. Maybe, we cannot predict exactly, but we can tell roughly. Okay, I'll explain. Now, so basically RT means reliability. Okay, very important. Okay, you can see. Now, do you think an aeroplane is reliable? Aeroplane, the passenger aircraft. It's actually very reliable, honestly. Compared to a car, statistics show that a person, right, normal person may actually die from when they drive because can meet accident, right? Yes. But aeroplane is not. Why? Because aeroplane very, how to say, very safe because they have what we call redundancy. I don't know whether you redundancy. Redundant. I think my spelling is correct. Redundancy means what? Means you got backup. Yes, correct. You all very careful. You must backup. One landing gear cannot, must put 2. Backup in case one fail, switch to the other one. You know what I'm saying? If my battery fail, I got another backup battery. Something like that. Even the aeroplane, the jet jet turbine, right? If one fail, the other one you can still fly, no? You can still fly with one turbine, with the engine, the jet engine, because the plane can glide, right? Glide. So even one fail, still can fly. That's why you have two. Okay, so redundancy is something called extra. Okay, but extra come at a cost, right?
Yes.
Everything you can put, everything you also can put extra, right? Now, everything double up. Okay, will bring extra, but yeah, it comes at a cost. You pay for it, right? Yeah, confirm, right? You buy put extra, you pay. Okay, now, so there is the other term is called unreliability. Later I'll show you one short YouTube clip. Okay, you will find it quite interesting. Okay, now of course there's another term called unreliability given by FT. So it's the opposite of this, right? So it's unreliability. But would you agree with me that if reliability plus unreliability must be equal to 1? Does it make sense?
It's theoretically, practically not make sense.
Doesn't make sense. Why?
If I got a better one, if I mix with the good one also come back.
No, I'm talking about the same thing. Same thing, the in terms of percentage. If this chair is, if I tell you this chair is 95% reliable, so what is the probability that the unreliability? Because you must round it to 100%, everything be right now. So that means this chair got 5% unreliability. There's a possibility you break, but 95% most of the time is good. Okay, so this is the thing that we have to bear in mind. We have this handphone, maybe this thing is 95% reliable. That means there's a probability 5% you will fail. Okay, so reliability plus this must be equal to 1 because you cannot be more than 1. Okay. Now, so now this one is just for your info. Okay, now when they manufacture a lot of, if you are in the manufacturing sector, you manufacture things, right? Like hard disks, computer hard disks, or phones. Okay, now you always have this curve. This is what we call a reliability curve. Now, usually your product, the product that you have are in this range. Now, do you know that hard disk, computer hard disk, they always give you a warranty. How long? Hard disk. Lifetime, no lifetime. They give you, even very good, they give you 3 years warranty, right? Because actually they are very smart. When they make product, they already know. Like car, how long can you use for a car? They have a certain lifespan. They know that after a certain lifespan, the thing will start to wear and tear, will break down. They actually already know. Okay, so now most of the time your product that we use are in this range. Because how to read this graph, this is time. This is the failure rate. Okay, failure rate. You can see here. Failure rate. That means if you are very high up here means no good because you are going to fail. You see what I mean? This one high means no good. You want it to be low failure rate. Okay, now so when you first manufacture a product, right, the failure rate would be very high. That's why they do QC testing. They will test those rejected one. They will put one side, kick up. Then they test. Okay, then they can roll out to the market, right? So this is the one. This one means that you pass the QC. Okay, go to the consumer, sell my iPhone or whatever, and go to the people who buy. Right, but after the consumer buy the phone and they use it, let's say, or anything, any electronic or any product, they will use for a certain lifespan. Then this thing will it will accelerate to failure. Okay, does it make sense? You think you will get it? Okay, now maybe before that, maybe let me just show you. Short one. I show you this, you probably have seen before. Very quickly, yeah, chair. You probably have seen before. Very quickly, just quickly show you. This one, yes. This one is my favorite example to show. Very quickly, have you seen this before? Yes. Why are they showing you this? What is this? You see before I think no more already. This one they took out where they put it. But last time you used to see it.
They got only one drawer.
Oh, they put okay. So why am I showing you this? Because this thing is testing, right? They are testing how many cycles, right? You can see this thing, okay? So you can actually see that they are actually trying to test this chair for the reliability. Oh. Okay, so it could be done in like how many cycles? Oh. So it's actually testing the system. Today this one not behaving very well. Okay, come. Corrupted or virus. Meantime, okay. Okay, now let's quickly talk about this one. Okay, there's this thing called mean time between failure, MTBF. It sounds very cheap. This word, okay, but what it is that what it's trying to explain is that it's the average time between faults occurring over a period of time. Okay, so now just take note that this symbol, right? This symbol is called lambda. Lambda is a mathematical symbol. Okay, lambda. So it's actually equals to 1 over this eta, right? They call it eta or something. Eta, right? Call it eta. Okay. Now later you got some examples, then you will see how this thing works. So basically, this thing is the failure rate. Okay, it's 1 over this eta. Okay, now let's see what it means. Okay. So this MTBF, mean time between failure, okay, is expressed as this, where T is the total test time. Okay, because we talk about reliability, we must test a product. We test it over a period of time. We have a test time, right? You must test it over a period of time before it's ready. Do you know that your medicine, right? If you want to get in US, you want to get your antibiotic, let's say approved, you need about 10 to 15 years. You know that? Let's say a medicine, right? In order to be approved, and then before you can go to the market to be for people to buy and to take, you need at least 10 years. Under the FDA, America got this FDA, Food and Drug Administration, 10 years in one job. Okay, so coming back to here, so they need a test. Okay, you need a test time. Where R is the total number of failure. How many times? Yes, because I may produce 10,000 of this item, right? But there will be some who fail. Okay, where R is the total number of failure. Let me give you an example. Okay, now look at this simple example here. It says that, okay, I have a sensor. Okay, I have a temperature transducer or a sensor. Okay, the total test time was 316 hours. Okay, now I may have many. Okay, but when I test this, okay, 4 of them fail. Okay, during these 316 hours that I've tested, I got 4 of them fail. Okay, what is the estimated mean time between failure? Okay, what you do is this. Okay, you will take 316 hours, you divide by 4. So on average, about 79 hours, one of them will fail. That's the meaning. Okay, you see what I mean? Okay, so this is a very quick example just to explain to you. That means over the total test time, I got on average, after 79 hours, one will fail. That's the meaning. Okay, so it's called the mean time between failure. MTBF. This one. So those in the box are very important. You must try to remember. So in the box. Okay, now how much time do we have? Okay, so now moving on, probably my 2 more slides. 2 more slides and I'm kind of done. Okay, so very quickly. Now reliability, RT, right, is given by this formula. You all know how to press your calculator for this? Yes. You all know how to press? It's important. E. Later, the next page got one very good example here. Okay, let's take a look. So your RT, reliability, is given by this E minus lambda over T. What is lambda? This symbol is called lambda. Okay, lambda is given as this one. Lambda. Okay, So that is reliability, and unreliability is 1 minus, because you know why is it 1 minus? Because from here, right? Okay, gentlemen, from here, how to get the FT? Bring it over, right? Bring this one over to the other side. Right or not? Is equals to reliability minus 1. Okay?
1 minus.
1 minus, sorry. FT, right? You're looking at FT, yeah. This one bring over, it's minus, not the other way around. So it's 1 minus. Is it okay? From here. Okay, one more final example and then off we go. We are done. This is the two expression. Now let's take a look at this one. Okay, very quickly. Now, if you say that I have a equipment, right? Some equipment in the plant, okay, I have this failure rate. I give you the failure rate. So on average, you will fail about 0.001 per hour. Okay, so I can calculate what is the MTBF, because MTBF is 1 over this lambda, right? See whether you understand it. Yes, this one. This one, lambda is 1 over theta. This one, theta is this one. Okay, so we can work out this one. Okay, you are given this. Okay, you can T is the time. How many hours you test the thing over a period of time. So you want to find the reliability RT equals to this, right? T minus lambda over T. So you will substitute T, which is 500 hours, into here, which is over here. You put the T at 500 equals to E minus this number. This times the time, how long you test. So there is a probability of 60% reliable. This item 60.65% reliable. Okay, without failure. Any question, this one?
So all the while the period will be in hours.
No, later can be in cycles also. Not necessarily time, because time is one thing that you can use, right? Just now I showed you the IKEA chair, remember? The one is go by cycle, because the one maybe the compression, they want to test the chair, right? They keep pumping this fella, right? Like that is 1 cycle. Like that again, 2 cycle, 3 cycle, 4 cycle, maybe 15,000 cycle. This thing can keep pumping the chair. So not necessarily is by time. Good question actually. Not necessarily by you test by time, it could be by cycle. You see what I mean? The chair now, right? They actually do the test, but they go by cycle, no? Like that. Press one time is 1 cycle. Press again, 2 cycles. Press again, 3. Press again. Can continuously do it, right? Maybe 15,000 cycles until the chair breaks down. Okay, so it could be by cycle as well, not necessarily time. Okay, so that one is the next one. I think you all overload already. I think I won't cover it. Then I will do it again another time. Okay, so this one could be also be by cycle. Mean cycle. Instead of by time, could be by cycle. Have you all signed your attendance, gentlemen? Who haven't signed? You sign, Okay, if not, I think good night. I'm done for the evening. Alright, so I'll see you next week.